Welcome to the Explainer. All right, we're going to dive right into this because we are literally living through the most massive transformation in software engineering since the invention of high-level programming languages. For decades, right, a developer's primary way of talking to a machine has been syntax, typing out the exact curly braces, the semicolons, the precise grammar, just to tell a computer exactly how to do its job. Well, that era is rapidly coming to an end. We're moving toward a totally new software development lifecycle, a new SDLC, and it requires a fundamental upgrade in how we actually think about building software.
I want to kick things off with this quote because it hits the nail right on the head. The most profound shift in software engineering isn't a new language. It's the transition from writing code to expressing intent and trusting intelligent systems to translate that intent into working software. If you're an engineer, a CTO, or an architectural lead tuning in, this is the paradigm shift you absolutely have to internalize. The machine is taking over the implementation details. The human, we're now responsible for the intent, the big picture architecture, and the judgment calls. We are no longer just manual syntax translators.
Okay, so here's our roadmap for today. First, the shift to intent. Second, vibe coding versus agentic engineering. Third, the art of context engineering. Fourth, the AI factory model. And finally, the developer's evolving role. Let's get right to it. Part 1, the shift to intent. Just think about how incredibly fast this whole evolution is compressing. I mean, what used to take a decade has happened in like 3 years. Back around 2021, we just had simple autocomplete, the editor just guessing your next couple of characters. By 2022, boom, we had inline code suggestions knocking out entire functions. In 2023, chat-based generation meant you could describe a feature and get an implementation. But look at 2024 through 2026. We're rapidly entering the era of fully autonomous agents. These systems can clone a repo, plan the architecture, execute changes in a secure sandbox, run the full test suite, and submit a PR completely on their own. Literally zero human keystrokes required. Now, it's absolutely crucial to understand that an agent is not just a glorified chatbot. A chatbot basically spits out a response and then sits there waiting for you. An agent, on the other hand, runs its own continuous loop. It perceives a goal, it plans the steps to reach it, it acts by pulling on tools, it observes the results of those actions, and then it iterates. If a result is bad, it just self-corrects and replans. It runs this loop entirely independently until the goal is met. This loop is the beating heart of every autonomous coding system out there today. Moving on to Section 2, vibe coding versus agentic engineering. Okay, so on one side of the spectrum, we have vibe coding. On the other side, agentic engineering. Let's be super clear here. If you go tell your CTO that you're currently vibe coding the company's core payment processing system, yeah, you're probably getting fired. And rightfully so. Vibe coding is totally fine for a weekend hackathon prototype, but production systems, they demand low-risk systematic validation. The real skill is knowing exactly where your current task sits on this risk spectrum. So how do we actually differentiate the two? The main difference isn't whether you're using AI or not. It's entirely about how the outputs get verified. In vibe coding, you're tossing in casual prompts, and verification is basically just you squinting at the screen going, does it seem to work? It's highly manual. Agentic engineering, though, that relies on formal specifications, architecture docs, automated test suites, CI/CD gates, and even other AI models acting as judges. Tests verify the deterministic parts, and rigorous evaluations check the non-deterministic reasoning of the agent itself. Section 3, the art of context engineering. The software industry has recently realized something massive. Success in this new era relies way more on high-quality context than on clever prompting. Welcome to context engineering. You have to provide your agents with really rich, structured information across 6 distinct types of context. You've got instructions setting roles and boundaries, knowledge like your domain data and architecture diagrams, memory of the current session state, examples showing few-shot reference patterns, tools like the actual APIs it can call, and finally, guardrails, which are your hard constraints. Seriously, if your agent is failing, it's almost always because it's missing one of these 6 pieces of context, not because you failed to trick it with a magic prompt. But here's the catch. You can't just dump all that context on the agent at once. You have to master the balance between static context and dynamic context. Static context is your global memory and core system rules. It's always loaded, which is super reliable, but it's incredibly token-heavy and expensive. Dynamic context is only loaded on demand when a specific task actually needs it, which maximizes your efficiency. Balancing these two, knowing exactly what belongs in static versus what gets pulled dynamically, that is the true modern skill of context engineering.
Because of those heavy token costs, the absolute best systems treat the boundary between static and dynamic context as a first-class architectural decision. It gets reviewed and versioned just like normal code. By utilizing agent skills, which are essentially portable packages of knowledge that get loaded dynamically, your agent stays a lightweight generalist that can instantly flex into a domain specialist right when it needs to. This stops the agent from forgetting important rules due to context rot and keeps you from wasting thousands of tokens on completely irrelevant background noise.
Section 4. The AI Factory Model. Welcome to the AI Factory Model. Are you ready for this? A developer's primary output is no longer code. I really want to emphasize that. Your output is no longer code. It's the factory that produces the code. Think about it like this. A factory manager doesn't sit there assembling widgets by hand, right? They design the assembly line, they tune the machines, and they set up the quality control gates. The modern developer defines the specs, designs the guardrails, sets up the verification tests, and then lets the agents run loose on the factory floor to actually assemble the software. Inside that factory, we have to understand this core equation. An agent equals the model plus the harness. Look, there's a huge temptation to treat the underlying AI model as the entire system, but the model is really just one input. When an agent does something wrong, our first instinct is usually to blame the model. Oh, the AI is just dumb. Actually, scratch that. Almost every single time, the failure traces back to a missing tool, a vague rule, or an absent guardrail. It's almost always a configuration failure in the harness. To put that into perspective, look at this breakdown. The raw model itself is actually only about 10% of the entire system. The harness makes up the other 90%. It's exactly like an engine versus a car. The model is the raw, powerful engine. But an engine sitting on a workbench can't get you to the grocery store. The harness is the chassis, the steering wheel, the tires, the paved road, and the traffic laws. The actual behavior you experience when using these advanced coding agents is completely dominated by that 90% harness layer. So what exactly makes up this massive 90% harness? Well, it's everything that surrounds the model during implementation, testing, and deployment. It's your instructions and rule files. It's the tools and APIs you give the agent access to. It's the secure sandboxes where the code actually executes. It's the orchestration logic routing the models, the guardrails and hooks ensuring it doesn't accidentally commit a hard-coded password to GitHub, and the observability logs so you can audit why the agent made a specific weird decision. This harness, this is your team's new surface area to manage. And finally, Section 5, the developer's evolving role. The modern developer is going to operate incredibly fluidly between two very different modes, the conductor and the orchestrator. The conductor is highly hands-on. It's real-time, synchronous work right inside your IDE, where you maintain keystroke-level control, basically guiding an AI pair programmer line by line. But to really scale your impact, you have to shift toward high-leverage delegation as the orchestrator. This mode is completely asynchronous. You're defining high-level goals for multiple different agents, stepping back, and then simply reviewing the pull requests they generate for you. You can already see how these workflows map to the tools we're using right now. In conductor mode, you're using inline completion and chat and editor tools. Think GitHub Copilot or Cursor to get that fine-grained control when you're doing exploratory coding or learning a brand new API. But when you switch over to orchestrator mode, you're spinning up background terminal agents or CI/CD integrations. You assign a massive framework migration and you walk away. The feedback loop is delayed, sure, but the scope of what you accomplish is absolutely massive. But of course, we have to talk about the 80% problem. AI agents today are phenomenal, literally mind-blowing, at rapidly generating about 80% of the code for a given feature. But that final 20%, the weird integration points, the obscure edge cases, the highly specific correctness requirements for your business, that still demands deep, human, contextual knowledge. The best developers right now aren't trying to go faster by blindly accepting everything the AI produces. They use AI to absolutely fly through that first 80%, specifically so they can reserve their complete attention and architectural judgment for that incredibly difficult, crucial final 20%. Which leaves us with this final thought. We are officially leaving the era of manual syntax translation behind us. Intent is the new interface. The machine handles the how, but you, the human, must fiercely control the what and the why. So I leave you with this. Are you ready to stop typing syntax and start engineering context? Thank you so much for joining me on this explainer. I really hope you take these mental models back to your teams and start building your own agentic factories. See you next time.